Okay, this is NEET 2019. Okay, 2-point charges A and B. So there are two charges A and B having plus Q and minus Q. If you get a question, any question in physics, what you have to do first is draw that picture and draw the picture so that you will get an idea. So I have two charges. One is plus Q and another charge which is equal to minus Q. Clear? Great. Are placed at a certain distance apart. So they mentioned certain distance, but they didn't mention what exactly distance. So I'm just calling it as R. Okay, there is plus Q, there is minus Q, and they are separated by a distance called R. Is it clear? Fine. We all know that according to Coulomb's law, if there are two charges, there will be a force between them, right? There will be a force experienced. So that force is called Coulomb's force. And if that force acting between them is called F, and if 25% of the charge A, so there is charge A, there is charge B, and if I take 25% means what? We know that 25% if you want to convert into fraction, 25 divided by 100, how much it will get? 1/4. 1/4 of this charge, which means what? I have Q, 1/4 of this charge means Q/4. Okay, so Q/4 of charge I am giving to this guy, right? He is transferred to B. Is it clear? Is it clear? Then the question is, how much is the force after that? How much is the force after that? So let's see how much is the force before it. It's very simple, right? F is equal to, so I am talking it before. F is equal to K into Q minus Q divided by R square. This is clear? No issue. So I can write it as minus K Q square divided by R square. This is the force before. There is plus Q, there is minus Q, and I am transferring Q/4 charge. So how much charge A will be having? How much charge B will be having? Can you say? This guy lost Q/4, right? So it will be Q minus Q/4. How much you will get? You will get 3Q divided by 4. And this guy got plus Q/4. So how much he will be having? It will be minus Q plus Q/4, which is equal to minus 3Q divided by 4. Now force after this, see, it will be equal to K into charge of the first particle, which is equal to this, right? This is equal to 3Q divided by 4. Charge of the second particle क्या है? This is equal to this one minus 3Q divided by 4. And distance is same. Distance hasn't changed anything. So let's take out the constant. 3/4 here, 3/4 here. 3 into 3 how much? 9. 4 into 4, 16. So it will be minus 9 divided by 16. So I am taking minus here. Minus K Q square divided by R square. So I told you minus K Q square divided by R square is nothing but force before. So I'm just calling it as F. So here also in the question they mention it as F, right? So this is F. This is nothing but F. So I'm just giving 9/16 into F. So that will be the force experienced after you transfer the charges. So which is the correct answer? A, B, C, D, which is the correct answer? C, right? So let me explain this again. I have two charges, charge A and charge B. Charge A has plus Q, charge B has minus Q. Now there is a force between them, right? That force is nothing but this one, K into Q into charge of the second particle, which is equal to minus Q divided by R square. This is equal to minus K Q square divided by R square. This is clear. This is Coulomb's law. No need to worry about anything. Now, once I transfer the charge like this, I transfer the charge from here to here. How much charge I am transferring? Q/4. So this charge lost Q/4. This charge gained Q/4. So we can just simply add and subtract, right? So subtracting here, you will get 3Q/4. Adding here, you will get minus 3Q/4. This is also clear. Now, here charge changed, here also charge changed. Now definitely there will be change in some force. So let's see what happens to the change in force. Nothing, we will just use Coulomb's law again. K into charge of A into charge of B, which is minus 3Q/4 divided by R square. And we are taking all the constants outside, which is equal to 3 into 3, 9, 4 into 4, 16. Then I am keeping all the other terms together. Now we know that this is nothing but this term. See, carefully look at this term, minus kq square divided by r square. This is nothing but the force initially it was experiencing, right? So that is the force. See, this is the force acting between them before we transfer the charge. And if you just substitute that, you will get this equation. There can be, see, if you understand this question, there can be multiple questions like this. A charge adding, distance changing, what will happen to the force? You have to follow the same procedure. Force at the starting time, force after the changes. Then you compare it.